All right, welcome to another exciting chapter of business statistics. Here, Exploratory Lesson 13, we're exploring the path from cause to effect. So we learned with multiple regression that we have an incredibly powerful tool. We can include multiple independent variables and use them to predict a dependent variable, and the multiple regression results will tell us the independent effect of each variable, x, on y. So we can account for third factors. In our great question of how do we figure out if x is causing y, we have a powerful tool. We know that there's a number of reasons that x and y could be correlated. X could cause y could cause x. There could be some third factor causing both x and y, which are otherwise unrelated, or the result of the correlation could be completely random. We have learned a couple of powerful statistical tools. One, we've learned about the t-distribution and the distribution of possible sample means, which extends to our coefficients here for regression. We can calculate t-statistics and p-values that allow us to rule out that the correlation we're observing is random. Let's just cross out random as an explanation for the correlation between x and y. But there's still more. It's not necessarily that x causes y. Could be that y causes x. Could be that there's a third factor that's causing both. Multiple regression lets us cross off that third factor. If we can include the third factor in the regression and account for it, we're holding it constant while estimating the effect of x on y. If there's still an effect of x on y, well, the third factor, c, is being held constant, then it cannot be the explanation for the correlation we see. It can't be that c is causing x and y, which are otherwise unrelated. We find that they're still related even when we account for the effect of c on y. Okay, that's super powerful. Through theory, through research design, we can eliminate backwards causation. We can say like, oh, there's really no way that y is causing x. But sometimes we can't be sure that we've eliminated all of the third factors. There could be some unmeasurable things that are correlated with x and y that we can't include in the regression. There could be things we haven't thought of or haven't realized are having an effect. And so sometimes it feels like sometimes we're just out of luck. We can't really be sure. We could do our best to account for all the third factors, but we'll never be totally sure that we've accounted for them all. Well, then along comes better research design. Here in this exploratory lesson, we're going to explore this two-stage regression that we call instrumental variables, where we identify a variable that essentially does random assignment into a treatment and control group that we can then use to compare outcomes. Randomized controlled trials are the gold standard of scientific inquiry because they account for all of those third factors. By randomly assigning someone to a treatment or control, the treatment becomes uncorrelated with everything. And so we don't have to include anything else in a regression other than the treatment because we've randomly assigned it. And so now, through randomness, we've decorrelated it with everything else. Sometimes that's not possible. Sometimes we can't do a randomized controlled trial. For example, we might wonder, what is the effect of military service on someone's income later in life? You're not going to do a randomized controlled trial for that. You can't randomize a trial where you put someone through military experience that takes years and years. But if you're thinking about this, there actually is an instance where we did do that, and that was with the draft. The draft randomly selected people for military service, and then they had to complete that military service, whereas people who were not drafted did not have to complete it. There's a lot to dive into, and hopefully you watched the Josh English video about this after he received his Nobel Prize in Economics. He gave that lecture that's included here. There's lots to consider about this because the draft is not perfect random assignment. Some people dodged the draft, as we know. They were able to evade the draft and not be a part of it. Some people were drafted and it was determined they couldn't serve in the military, or they otherwise escaped that service. Some people were not drafted and chose to serve in the military anyway. So there are these are often referred to as the never takers, the always takers, the sometimes takers, and so that's in reference to the treatment. Will they take the treatment? And so instrumental variables is a powerful way of using regression to basically create and solve that random assignment problem and account for all of those things. So that's what we're going to do here, and we're going to kind of see that this works. So Josh English did this as part of his PhD thesis, and he found that military service in Vietnam, for those who were drafted, had the effect of about negative $5,000 on their earnings later in life. Now, as I said, this is only applicable to the situation that we describe. So this really gives us a great estimate of the effect of military service in Vietnam on people's income later in life. It might not reflect military service today and its effect on people's income, but this is at least almost surely true for the people of that time and for that war, because of the power of instrumental variables in helping us identify that truth. So as you can see in this sheet, I've created a new function. So this does not exist normally in Google Sheets, but Google Sheets gives you the power to create functions, which is very cool. And it's called linreg. So we're going to use that. We're going to use linreg in this sheet. And you can see we've got this detailed formula about how it works, some explanation of it that I put in here. We want to do a regression where the dependent variable is income. And so I need to slide this over so that I can see income in column A here is what I'm going to select for Y. And then I can include up to 3 variables, which is what I need because I want to include, what do I need? Education, experience, and a constant. So I'm going to include education. Oh, and of course, I'm sorry, the first one is, of course, military service. Military service, education, and experience. I don't need to include a constant. It knows about the constant and is taking care of that for us. But I do need to tell it that the first row of my data is variable names. So I'm going to put true there and hit enter. And boom, here we have our coefficients for each of those things in the order that we put them in there, and then the standard error. So now we can calculate our t-statistic, which is just the coefficient divided by the standard error. We could calculate our p-value, where we're going to do t.dis.2t. We're going to have to do the absolute value of our t-statistic. Our degrees of freedom in this case, we're going to want to compute here, so we can do count to count up the number of numbers using our dependent variables, usually best. And then we need to subtract the proper number of variables that we included. Here we have 4. Military service, education, experience, and the constant. So we need to subtract 4 from this for our degrees of freedom. And there's our p-value. Then we can calculate an upper bound and a lower bound using our inverse.2t, where for our probability, we're going to put 0.05. And for our degrees of freedom, we're again going to have to do our count. And we'll subtract 4 from that. So that gives us our critical value for t that we multiply by the standard error. And I'm kind of doing it out of order because at the beginning here, we're going to want to put the coefficient for the lower bound minus that value. I'm going to copy this and put it over here in upper bound, but change that minus to a plus. I am hoping, as I'm doing this, that this is becoming second nature. You've done this t-statistic, p-value, upper bound, and lower bound so many times that I really hope you've got it. That you're like, yes, I totally understand. And then I want to compute whether or not this is true, whether or not we got it. So first, I'm going to take these, and I can extend them down here. Oops, not to this last row. Just down to there. So that we can get our t-statistic and p-value for all of these, and then determine if we found the truth. So here, of course, I've got data that we've created so that we can know the truth, and we can check and see. So here we're using our AND function to determine is military service the true amount greater than the lower bound, but also is it less than the upper bound. And oops, is I5 less than the upper bound? There we go. No, it's not. And of course we can see it's not. Negative 5,000 is not between these two values. So we've misidentified the truth. I'm going to throw some dollar signs into this so that I can drag it down. And then, you know what you could do? Here, let's do a different thing. Let's instead put this here, put this here, put this here, and put constant here. And then instead of I5, I can point at Q10, which will stay the same. And now I can just drag this down, and it will, now this will point at the correct one, and we can see these other ones it's getting right. Those aren't biased by things, by the randomness of the universe. And so here, if we just look at military service, the effect of military service on income in our regression, we're getting it wrong, even when we account for education and experience. It looks like military service is much worse than it actually is, at least military service in the Vietnam War. And so we want to figure out what is the actual causal effect of that on income. And basically what we're finding is military service is too correlated with stuff we did not include in this regression. There's too many other variables that affect income that also affected people's military service. So you could just think, parents' income is an obvious huge one. Like, what is your socioeconomic status? If you were super rich, you got out of the Vietnam War. We've seen that over and over again with public officials who did not serve because they were rich. And so there too, we would expect them probably to have high incomes later in life because they have the privilege of that upbringing. And so we would expect military service to be biased by not including these things. And indeed, we see here in my made-up universe, it is. It's biased. So we're out of, what are they? What are all of the things? Maybe we'll never know. Maybe we won't ever be able to figure out all the things that would affect military service and income to include them in this regression. But we don't need to, because there was a draft. And the draft essentially randomly assigned people to military service. So that's what we're going to do. Instead of trying to predict income, let's try to predict military service. And we'll use the draft as the thing we're going to predict with. So we're going to use linreg again. And linreg now, our dependent variable is not income, but military service. And we want to predict military service with education and experience. So with the draft is the first one. Sorry, I keep missing the first one. The draft is the first one we want to put in, column D, and then education, and then experience. And that's the order they're in there. And then it's true. The first row is the variable name. So there we go. Being drafted basically increased the probability that you would serve in Vietnam by 35 percentage points. So if you had a 10% chance of serving in Vietnam, getting drafted increased that to a 45% chance. So still a lot of draft dodging that we have built into our here made up data. Still a lot of people who manage to avoid it. But now that we've accounted for it, now that we've included this draft in here, we're basically giving people probabilities with this prediction. So let's go ahead and get our upper bounds and lower bounds. I'm just going to copy from this row and put it in. This is the beauty of spreadsheets, that now all of our cell references have moved to the appropriate ones. And this totally works. We still have n minus 4 degrees of freedom. And so we fill this in and we get, please stop suggesting things. We get these results. And we can see they're all highly significant. So we are now predicting military service. And that's what we actually have to do. We're going to predict military service. And so I need to take our variables here. So I'm going to do a complicated thing here. It's some product where we want to multiply each one of the coefficients that we have here by each one of our variables. So we actually can't include the constant. So I'm going to delete that. We got to do these three variables, and we're going to multiply them. I'm going to have to transpose them because we have them in a row over here. But we're going to take these values for drafted, education, and experience and multiply them by the coefficients. And then we're going to add the constant. We definitely want to lock in our references to J here so that those don't change, but we want our references to the row to change for D2 to F2. So that's what we need. There it is. This formula, again, is just computing our predicted value for military service from the results of the regression. And so this person has a 40% chance of serving in the military. And they indeed did serve in the military, even though they weren't drafted. So that's what we're predicting here. That's what we're getting with this thing. And I'm going to let that extend all the way down and basically get kind of a prediction as to whether or not a person has served in the military. And that prediction is based on the draft. Did they get drafted? And how did that affect our prediction of them serving? And so now this is going to become our dependent variable. We've removed everything that affects military service that is not the draft, education, or experience. The things that we can account for. The draft we believe to be random. It randomly assigned people to military service or not. Sometimes that assignment worked, sometimes it didn't. Sometimes people who weren't assigned did go, but nevertheless, we are channeling all of our explanation of military service through the draft. And so all that's left over in our predicted service is what can be explained by these three variables. So now I'm going to do a regression where my dependent variable is again income. We're back to income, and I can see that right here. And my independent variables are now predicted service, education, and experience. I mean, I'm still including those variables in here, so because we still have that inside our predicted service. But this gives me now the coefficients for predicted service on income and education on income and experience on income. And I can, of course, so I am going to do the same thing here. I'm going to plug these in and stretch this down so I have the true numbers right next to our cells here. And then I can just take my t-statistic all the way through. All of this can come along and we can compute, does it get it right? And indeed, it does. It gets it right. Because the draft is random and uncorrelated, with everything else. If we use it, so it's correlated with military service, but not with anything else. Not with anything else in the error term. And because that's the case, if we use it to predict the variable of interest, military service, then the predicted values that we get from that regression are the part of military service that can only be explained by the draft education and experience. And if we take that and we use it to predict income, now we get the effect of military service on income independent of everything that isn't the draft education and experience, which tells us now the effect of military service on income, that we can now properly estimate it and see what the true result is, because predicted service is definitely uncorrelated with everything else. And the only way for the draft to affect your income is if it passes through military service. So the causal effect of the draft on income has to go through military service. The draft affects military service only, and military service then affects income. And so we're basically able to use the draft like a little switch, like a toggle that toggles military service on or off. And then we can see the effect of military service by itself, uncorrelated with everything else. So this research design is enormously powerful. If you can find out in the world something that is essentially random assignment towards some treatment, then you can properly identify the causal effect of that treatment. That's amazing. And this has been an incredibly powerful tool across economics, which it has completely broken open into a whole new research regime where this is being done to test theories, to figure out how the economy works, and also in business, where you can use these sorts of random assignments to figure all kinds of things out, like what are the effects of these advertisements on our sales? What is the effect if we change their social media feed to look like this instead of that? What will happen? It's an incredibly powerful tool that I wanted you to all see, to know that exists, so that you could take home the main conclusion, which is, if we want to know whether or not X is causing Y, we need to do proper statistics that account for randomness, that account for third factors that could be affecting X and Y, and that consider a proper research design, experimental design, that helps us eliminate all of those other third factors, helps us eliminate randomness, and helps us eliminate reverse causation, so that we can conclusively say, with high degrees of certainty, that X does in fact cause Y. That's the power of statistics. That's the promise of it if you do it correctly. And hopefully, through your lives, you will do it correctly. Okay, that's this exploratory lesson. There's one more, and I'll see you on that one.